Today we're going to look at the car passing the truck problem. Let me remind you what it says. A truck enters a highway driving 60 miles per hour. Car enters the highway at the same place 11 minutes later and drives 73 miles per hour in the same direction. From the time the car enters the highway, how long will it take the car to pass the truck? The only thing I can think of worse than this would be if there were two trains and they were both heading right at you. So let's see if we can figure out what to do with this problem. First of all, I've got a truck and I've got a car. And I know that I needed to tell you what those were because otherwise you would not have known. Anytime we deal with a car or a truck or a train traveling a distance, we need the distance formula. I'll remind you the distance formula is distance is equal to rate times time. And we're going to need this for both vehicles. So let's look first of all about what we know about the truck. In looking at the distance formula, are there any values I could plug in? Well, I don't know how far he's traveled, and I don't know how long he's traveled. But the one piece of information I do know is that he's traveling at 60 miles per hour. That's his rate. So let's plug that in. Now let's look at the car, and let's talk about him. You should be able to pick up now that you can plug in his rate of speed for R, but there's one other piece of information that you need to recognize. I can also plug in something about his time. I don't know how long the truck traveled, but we called it T. I do know that the car traveled 11 minutes less than that because it left 11 minutes later. So whatever value the truck traveled, T, the car traveled 11 minutes less than that. So let's see what that looks like when we plug it in. His rate of speed, 73 miles per hour, replaces the R, and T for him is the same time that the truck traveled minus 11 minutes. So I end up with the equation D is equal to 73 times quantity T minus 11. Now, here's where this one gets a little tricky, and you may not have picked up on this before. Think about this for just a minute. They've both traveled the same direction. They're traveling at different speeds, and they travel a different amount of time. But they travel the same distance because the car catches up with the truck. So whenever the car catches up, the distance here will be the same as the distance here. Well, I need you to think about something for a minute. If this is equal to D and this is equal to the same D, then the step I need you to make is that this is equal to this. They have to be the same because they're both equal to the same distance. The way we'll write that now in the equation is to do exactly that. 60t is equal to 73 times, open parentheses, t minus 11, close. Now, that's the big jump for this whole problem. So let that one sink in for a minute. And from there on out, we'll just do some basic algebra steps. We'll distribute on the right, and we'll get 60t is equal to 73t minus 803. Subtract our 73 from both sides, and I get negative 13t is equal to negative 803. I need to now divide both sides by negative 13, which gives me t is equal to 61.769. I do want to remind you that when you were doing this problem in my math lab, they ask you to round to the nearest minute. So we'll do that by saying 62 minutes. Now remember, t stands for the amount of time traveled by the truck. We happen to be asked the amount of time traveled by the car. That's what they want to know. How long does it take the car to pass the truck? Let me remind you, the car traveled 11 minutes less. So we need our 62 from right here minus 11 gives us 51 minutes that the car has traveled. So right here is the answer to your problem. 51 minutes is how long it takes for the car to catch up with and pass the truck. Now, this problem doesn't ask you for the information I'm about to talk to you about now, but I do want to make sure that you understand as much as you can about this problem. What if instead of asking you how long it would take for the car to pass the truck, they ask how far would they have traveled when the car caught up with the truck? So let's look at that. This time we'd be looking at distance. Well, we know that we can calculate distance using distance is equal to rate times time. So if I know the rate of speed of the truck, which I do, it's 60, and I know the time that he travels, I can calculate his distance. The only problem is this time is given in minutes. and his rate is in miles per hour, not in minutes. So the first thing we'll need to do is to convert this to hours. Well, there are 60 minutes in each hour, so I'm going to do the division. 62 divided by 60 will give me 1.033 repeating hours. Now what I can do is take this and plug it in right here for his time. So his distance will be equal to 60, which is his rate of speed, times 1.033, which is his time in hours. When I multiply that, I get 61.98, which is the miles, and let's round it to 62 miles, that the truck has traveled. It happens to be a coincidence this time that these two are equal, and it's only that case because he was traveling 60 miles an hour. Let's now look and make sure how far the car traveled. Well, he traveled this part of an hour, 51 divided by 60, so he traveled 0.85 hundredths of an hour. If I multiply that times his rate of speed, his distance is 62.05. There's a little rounding in here, but if I round that off, I know that he has traveled 62 miles as well. So it is indeed true that when the truck has traveled 62 minutes and the car has traveled 51 minutes, both of them will have traveled 62 miles and the car will have caught up with the truck. I hope this helps with the car passing the truck. Don't know what it does for those trains, but maybe it'll help you with this one. Talk to you later. Bye.